So we're going to pick up with the notes section, and this is going to be on the front of the second page in Unit 5, Lesson 10, where we began looking at domain and range. Some of you, depending on your class period and who your teacher is, you may have already looked at these notes and gotten them down. And if so, feel free to just move a little bit ahead to Activity 2, kind of skip forward a little bit in the video. But if not, we're going to go through and discuss a couple of these key vocabulary terms, what they mean, how they're represented, things like that. So, domain, anytime we see that phrase, that is referring to the set of all possible inputs for a function. Or we would typically know these as the x values of the function. And if domain is the set of all the possible inputs, the word range then refers to the set of all possible outputs for the function. And the outputs are, again, typically going to be your y values. Now, as we have seen in Activity 1, where we sometimes have values that only make sense in context for whole number values, or even in some cases, certain decimals, but not all possible decimal values. Any of these cases where there are limitations on what types of numbers we can use, where we can't just say any number bigger than 0, we have to kind of limit it a little bit more, maybe to whole numbers or integers, things like that. That is what is known as a discrete data set. And what we see on our graph is simply a set of points that make up the function itself. So we are only allowed to use certain discrete values, the idea here being specific numbers and not all possible values, including decimals, fractions, things of this nature. Meanwhile, we also have continuous graphs. And continuous graphs, these would be things like when time is one of our variables, we can measure time in fraction or decimal parts. And so in those cases, we may see a graph where it actually does make sense to draw a line or a curve to reflect not just certain points, but all the points and combinations of values, inputs and outputs in between specific points. Okay. So when you see these phrases, discrete or continuous, we're thinking about what type of input and output values are we expecting? Are they only happening at certain points for maybe whole number values? Or is it also going to include all decimals, fraction values in between specific integer points? So just to kind of give you a little bit of an idea before we get into this next problem and kind of summarize what we talked about yesterday. So now activity 2, again, some of you may have already done this. If so, check your answers and then move forward. But this problem relates to download speeds. Download speeds are important for loading a website, streaming music or videos, or playing games online. Download speeds vary throughout the day and are often impacted by how many people are online at any given time. The graph of function d represents the average download speed as a function of, again, I'm going to pause anytime I see that phrase, highlight it as a function of the number of hours since midnight. So, as we've discussed in my class, the output is always a function of the input. So, this tells us that the average download speed is going to be our output, given by the letter capital D. And then our input is going to be the number of hours since midnight, given by the variable h. So we're going to see h as the input, d of h would technically be our output. Now, the graph has a little bit of a typo here. This should say hours since midnight. I think there was just an autocorrect where it said house. But hours since midnight, or h, is going to be our input. And then the download speed as a function of the hours, d of h, is going to be on our y-axis for our outputs, average download speed in megabytes per second. So our task is to find each of the following and explain what they mean in the situation, starting with part A, d of 0. Notice where this 0 is. Inside the parentheses tells me that's an input value. So if we know the input is 0, that would be 0 hours since midnight, where do we have a point on this graph? I'm going to highlight this. Part A could be answered by looking at this input-output pair right here. Okay. So the point 0 for the hours since midnight as an input value looks like it's paired with a number right in between 800 and 850. I want to say that that's going to be about 825. Okay. So the point on the graph is 0, 825. And in function notation, we would say d of 0 equals 825, or approximately equal. If it's not exactly that, it looks really close to being right in the middle. So what does this mean in the situation? Well, 0 hours since midnight at that time, and that's kind of an awkward way of saying it. So I would probably put it in more normal language and say something like at midnight, the download speed is 825 megabytes per second, Mbps. Okay. Question or part B. I'll highlight this one in pink. D of 3. So we need to go to where 3 hours would be. That's going to be right in the middle of 2 and 4. If I look up, that's going to take me all the way to this very top point. Okay. So it appears that D of 3 equals 1,000. Again, the point on the graph that I saw that was right here where x equals 3, looking straight up, got me to the point 3, 1,000. And the meaning of that would be 3 hours since midnight, or at 3 a.m. The download speed is about 1,000 megabytes per second. And again, you may know this, but if not, 1,000 megabytes is approximately 1 gigabyte. So anytime you hear people talking about gigs of data, that just means 1,000 megabytes. So this would mean that the download speeds are happening at about 1 gig per second at this point. So really close to 1 gig if it's 1,000 megabytes per second. Then we finally get to part C, very similar, but also somewhat different. We still see function notation, but this time we are not given an input like we were in A and B. Both of those, we had the number inside the parentheses. Now we have a number outside the parentheses. We don't know the H, the hour input, but instead we know the output, which is going to be the download speed, is 750. So for this one, I need to find where 750 is and look across on the graph for any points that have that output or that Y value. And it actually looks like we have a range of values starting at hour 12, going over to hour 14. And if I scroll up just a little bit, I've got this little, toolbar on the right-hand side here that was kind of in the way. Looks like there's also another point right there. So we have actually several inputs that give us this output. So it looks like from 12 hours since midnight, that would be 12 in the afternoon, or 12 noon technically. So 12 p.m. to 2 hours after that, 2 p.m. 14 hours since midnight is technically 2 p.m. From 12 to 2 p.m., the speed is 750 megabytes per second. And I'm kind of abbreviating. Technically, it's average download speed. But the average speed would be about 750 megabytes per second. And then it looks like a little after the 22, maybe 23, maybe a little bit less. We could say maybe 22 and a half, something like that. So 22 and a half hours since midnight. If I break that down just a little bit, 22.5, I could think of that as 12 hours plus another 10 and a half. So adding 12 hours to midnight would be noon, then another 10.5 hours. That makes a total of 22.5, but 10.5 hours would be 10:30. So from 12 to 2, the speed is 750. Also at about 10:30 p.m., the speed is 750 megabytes per second. So several times during the day where we had this particular download speed. Okay. Now let's go to number 2. Describe what happens to the download speed on each of the following intervals. Now, when we're describing what's happening on these intervals, what we're going to focus on is, are they increasing? Are the speeds increasing? Are the speeds decreasing? Are they remaining constant, or some combination of those? So from 0 to 3, that's this first piece of the graph right here. It goes up and then it continues to go up. So I'm going to say for that one, it is increasing on the interval from 0 to 3. What about from 14 to 17? Well, if we look at the graph here, start at hour 14, we are going down, down, down till we get to right about there in the middle at 17. That appears to be decreasing for the entire interval. And then from 21 to 24, it's going to be right here, going up, 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 up. It looks like it is increasing the whole time. Now, we could be a little more detailed. Maybe we could say that it appeared for parts B and C, they were increasing, part B was decreasing, but then part C was increasing, both at a constant rate. We didn't see any changes in the steepness or slope. And then that first one increased, but then it increased at a slightly different rate. So that one, part A, was not a constant rate. It was actually 2 different constant rates, one from 0 to 2, and then another from 2 to 3. Let's move on to number 3 now. Estimate the average rate of change. Again, estimate, because we don't know exact values typically from a graph, especially if they're falling in between specific numbers. But we're going to estimate the average rate of change between hour 3 and hour 14, and then explain what it means in this situation. So at hour 3, we mentioned earlier that we had a download speed of about 1,000. I'm going to write that point down again. And then for hour 14, that's going to be this point right here on my graph. It looks like we have a download speed of 750. So remember that average rate of change is found by doing the change in your outputs. Remember, the little triangle symbol is the Greek letter delta, which in math represents the word change. We just use it to keep us from having to write the word change so often. But we take the change in our outputs divided by the change in our inputs. Let's think about this. If my output speed at hour 3 was 1,000, and then at hour 14 it's now at 750, I've decreased. So I take the number where I end up minus the number where I started. 750 is where I ended up at download speed for hour 14, minus the 1,000 that we started at. I'm going to go ahead and simplify that. The difference between those two numbers is 250. But because I started at a higher value and ended at a lower, this change is a negative 250. If you go to Desmos and type in 750 minus 1,000, you get negative 250. But I also need to then compare the change in my inputs. So if I start at 3 and I end at 14, the difference could be found by taking where we end up, 14 for the hour, minus the hour where we started, which was 3. And 14 take away 3 is going to give me 11. So at this point, I would just go and type into either a phone calculator or just go to Desmos. You could even Google this one and just get a decimal value here. But we're going to see an average rate of change of negative 250 divided by 11. If we put that in some terms that make a little more sense, that's about negative 22.7 for our average rate of change. But what does that mean? What is this number telling us? Well, we have a negative average rate of change, which means the outputs are decreasing on average. And that makes sense because we started with a speed of 1,000 and we ended up at 750. So the speed is dropping. So we would say it is an average rate of change of negative 22.7. Then we mentioned the units for our output for the speed. And in this problem, that's been given as megabytes per second. And that's happening per or for every input unit. Since my inputs are times measured in hours, this would be per hour. So the average rate of change from hour 3 to hour 14 is a drop of 22.7 megabytes per second per hour. So speeds are decreasing about 23 megabytes each hour. Finally, number 4, determine the domain and the range of this function d of h. So let's focus on domain first, our inputs. If we're thinking about this, these download speeds are hours since midnight. Now, if we're measuring these for a single day, right, based on the graph we see, it appears that they're just looking at this for a single day. It seems like we would have all values from hour 0 to the next night at midnight, which would be 24 hours later. But notice that the graph had solid lines connecting all the points. That means this is continuous. We don't have to just have whole number values or integer values. We can use decimals. We can use fractions. That's not an issue at all, because if we think about it, you can have a download speed happening at 10:30, right? That's part of an hour, or at 10 and a fourth or 10 and a quarter hour, something like that. So the domain, we would say all numbers, or here's a better phrasing for that. We'll talk about why this is later. We would say all real numbers from 0 to 24. Now, if this function technically extended multiple days and we could sort of see multiple days ahead, then maybe we go even beyond 24 hours. Maybe it's a 2-day sort of function or a 3-day function. We would just extend it. But based off of the graph, it appears that it's going from 0 to 24. But we use the phrase all real numbers, not just all integers, because decimal numbers are also appropriate, fraction values are appropriate. We just don't see any negative values based on the description and based on what we see in the graph. So all real numbers, that would be integers, decimals, fractions, all of those from 0 to 24. Then we want to talk about the range. Based on what we saw in the graph, it appears that the maximum download speed is 1,000 megabytes per second. The minimum appears a little more than 650. Maybe that's 670 or so. Again, kind of having to estimate it. But then notice that the graph actually connects every point in between those two, right? It's a continuous graph that goes all the way up to 1,000. And then without kind of skipping any speeds along the way, it comes all the way down till we reach that bottom value at 670. So I'm going to say the range is all real numbers from the minimum, 670, to the maximum of 1,000. And again, these numbers are representing the speeds in megabytes per second, and our domain numbers were representing the hours of the day. Okay. So hopefully this helps you wrap up activity 2 and your notes. Once you have all of these things completed, again, pause the video if you need to go back and review anything. If any part didn't make sense, go back and watch it one more time. But then I want you to move ahead into the practice problems for lesson 10.